Today, we are going to practice problem solving, those dreaded word problems, using equations in lesson 2.2, and I'm going to kind of show you a little bit of how my brain works and figures problems out. Might be kind of scary, but hopefully it will help you. So I'm just going to give you several problems, and we're just going to talk our way through them. So be sure you complete these in your whisk. All right, your first problem says a 28-foot rope is cut into two pieces. One piece is 3 feet longer than the other. How long are the pieces? Sometimes it helps me to draw out a picture of it. So I just drew out what would be this rope, cut into two pieces. I know one piece is longer than the other. I know the whole thing is 28. And it tells me that it's cut into two pieces and that one piece is 3 feet longer than the other. So this must be where it's getting the start from to get the extra 3 feet. So this must be, I'm going to just assign this as X. This is my one part. And the 3 feet added to that X is going to be my other part. And if I set this equation, X plus 3 plus the other X equal to 28, and use my algebra skills that we've been learning and solve it for X, I'm going to know that this part over here is equal to 25 halves, or I could just say 12.5 feet. My question said, how long are the pieces? That would be this piece, this single X piece. Well, I need to know also how long is the X plus 3 piece. So over here, I added 3 to 12.5 and got 15.5 feet. So there's one problem for you. All right, here's another problem. Talks about Chris. Chris bought a baseball card in 1975. By 1985, the value of the card had tripled. And since 1985, the value has increased by another $30. And the card is now worth 5 times its original value. Well, how much was the card worth when Chris bought it? Well, I was told that by this time the value of the card had tripled. So I know that whatever that card cost, it was 3 times it now. So there's where my 3x comes from. And then since then, it has increased, that would be plus, by $30. So there's my plus 30. And when it says the card is now worth 5 times, I know it's now equal to 5 times what it originally cost, which was my X. So now I have my equation, and I can use my algebra skills by putting my variables on the same side and my constants on the same side and solving for X. And when I do that, I figure out that the original cost of his card was $15. All right, we're going to use one now that has to do with percentages. Sometimes this freaks us out a little bit, I think. Hopefully it won't after this. All right, the price of a mobile home was cut by 11% to a new price of $48,950. What was the original price? Well, I know that it was cut from the original price, right, by 11%. That's why I got my 11% times whatever this original price was. And it was cut, meaning it's less than the original price. So here's my original price. It's going to be, now it's less 11% of what that original price was. And I know it is what the final cost is now, which is $48,950. Well, what I know about percentages is if I multiply this, since it's by 100, not multiply, I'm sorry. That's how I turn it into a percent. But to turn it back into a decimal, I need to divide this by 100. Divide my 11, that's my percentage, by 100 to get it back into a decimal form. So I can work with that and solve the equation. So I divided it, I got 0.11. So I have the same equation with just this decimal form now. And I'm going to do what I know how to do, which combine my like terms. This is 1x. So I'm going to take away 0.11 from 1. I got 0.89x equals this big number. And when I divide by 0.989x, I get the original cost as being $55,000. All right, we'll see some like that. We'll work on those together. Another one type problem you might see deals with consecutive integers. This question says the sum of two consecutive integers is $35. What are the integers? Well, this has got to be one of them, and consecutive means one after the other. So the next number has to be one more than what this one was. So I labeled them x plus 1. And I know that the sum means addition. So the sum of both of those is 35. So I am going to combine my like terms, do my algebra skills like we've practiced, and figure out that my integer has to be 17. The other integer is one more, which is where 18 comes from. All right, so down here I put some guidelines for solving problems using equations, some things that you can think of when you're when you come across those dreaded word problems. All right, so first, if you've got two numbers that are consecutive, call one of them x and call the other one x plus 1. That will help you out. If you have two numbers that are consecutive odd or consecutive even numbers, that means that way you know there's one in between each of them. Call one of them x and the other one x plus 2. And then here's the one that kind of confuses us sometimes. If a number is increased by some percent, the new number, okay, is going to be x plus, you're going to convert that percent into a decimal, so you have to divide whatever that percent is by 100 to get it into a decimal and multiply it by x. Just like what we did up here in this red problem. Our percent was 11, and 11% of whatever that unknown number was. And so we divided 11 by 100 to get it put into a decimal form to help us work out our problem. So when we do our word problems, we're going to try to follow these guidelines to help us through. And we can do this. I have faith in you.